Hello everyone. In our last class, we have discussed about octet role. Okay. Now we are going to discuss one more important topic in our chemical bonding. Okay. Actually, what is chemical bonding? What is chemical bonding? The force of attraction between any two atoms or group of atoms that results the stable entity is called chemical bonding. Okay, the chemical bonding means the force of attraction between any two atoms. That means for example, the force of attraction between atom A and atom B or a group of atoms. Okay, between this atom A and the atom B, the force of attraction results the stability. Okay, stable entity. It results that stable entity. That is called as chemical bonding. Okay. And this chemical bonding is many types, but in our 10th standard we will discuss about the ionic bond and covalent bond. Okay, no? Ionic bond and covalent bond. In our 10th class we will discuss about these two kinds of bonds. Right? In this class, now we are going to discuss about the ionic bond. Right? Now we are going to discuss ionic bond. What is ion? The Cosell, the scientist Cosell, is given his observations on ionic bond, and he has given the definition as the ionic bond means the force of attraction between ions, two ions. That means positive ion or positive and negative. Okay, the positive and negative. His observations, every atom is trying to get stable electronic configuration. That means NS2 NP6. Every atom is trying to get a stable electronic configuration to get stability, like zero group elements. Every atom is trying to get the stable electronic configuration. Okay, and he said that ionic bond can take place between any two dissimilar atoms. Okay, ionic bond can take place between any two dissimilar atoms by the complete transfer of electrons. Okay, ionic bond can take place between two dissimilar atoms by the complete transfer of atoms. Okay, right. And in metals, like first A group, these atoms are ready to get the stable electronic configuration, magic electronic configuration, by losing of electrons, electrons. By losing, they are trying to get the stable electronic configuration. Okay, like then metals like 1A group elements are losing one electron. For example, sodium. Sodium's atomic number is 11. Okay, its electronic configuration is 1s2, 2s2, 2p6, 3s1. Okay, right? Then here it loses, it's trying to lose this electron, one electron, and after it gets the stable electronic configuration like 1s2, 2s2, 2p6, right? It get octet electronic configuration. So here how many electrons it has lost? Then one electron. Like magnesium, okay, its atomic number is 12. Magnesium, its atomic number is 12. Then its electronic configuration 1s2, 2s2, 2p6, 3s2. Right? 2, 4, 10, 12. Here magnesium is trying to lose 2 electrons. Here it loses only one electron, and it loses 2 electrons, and it achieves the octet electron configuration like 1s2, 2s2, 2p6. Right? That means here sodium becomes unipositive, and this magnesium becomes dipositive. Okay, like here aluminum's atomic number is Z equal to 13. Atomic number is 13. Then its electronic configuration is written as 1s2, 2s2, 2p6, 3s2, 3p1. 3s2, 3p1. Here to achieve the octet electronic configuration, it should lose 3 electrons. Then it loses the 3 electrons from its valence shell. And here you have to notice one thing. Here sodium loses 1 electron from where? From valence shell. Okay. And here magnesium loses 2 electrons from where? From valence shell. Here aluminum loses 3 electrons. It loses 3 electrons from where? From valence shell. That means here you have to came to know that the chemical bonding takes place by the losing of the valence shell electrons only, right? By chemical combination, by chemical bonding, the outermost electrons only responsible. Only the outermost electrons can be affected by the force of attraction or repulsion, right? And here then finally by losing the 3 electrons, it's gained the electronic configuration, stable electronic configuration 1s2, 2s2, 2p6. Right? That means now this aluminum becomes tripositive ion. Tripositive ions. These all are like highly active metals. Alright? Like the non-metals like phosphorus, its atomic number is 15. Its atomic number is 15. Then its electronic configuration, is written as 1s2, 2s2, 2p6 and 3s2 3p3 2 4 10 12 15, right? Then to get stable electronic configuration, to get octet configuration, it gains okay 3 electrons. Here these all are losing, but here it gains 3 electrons, and to get the stable electronic like 1s2 2s2 2p6 3s2 3p6, that means it becomes a tri-negative ion. Okay, right. Then next, sulfur, its atomic number is 16. Its electronic configuration written as 1s2 2s2 2p6 3s2 3p4, 1s2 2s2 2p6 3s2 3p4. Then to get a stable electronic configuration in its outermost shell, it gains 2 electrons. It gains 2 electrons to form a stable electronic configuration 1s2 2s2 2p6 3s2 3p6. Put it. And then chlorine's atomic number is 17. Okay, chlorine's atomic number is 17, and its electronic configuration is 1s2 2s2 2p6 3s2 3p5. To get the stable electronic configuration, it required 1 electron. It required 1 electron in its outermost shell. Then it gains it, and it get octet electronic configuration like 1s2 2s2 2p6 3s2 3p6. That means here it becomes, by gaining of 2 electrons, it becomes 2, then di-negative. It becomes uni-negative. Okay. Then we know that these negative positive charges, the metals are by losing their charges, losing their electrons, it becomes positive charge called cations, right? So metals are cations. And next, non-metals are by gaining the electrons here, they becomes anions. That means they are becomes electrons, then become negative charged one, and they call as anions. These charged particles are called as anions. That means the chemical bonding can take place in case of ionic bond between the charged particles like cations and anions, right? This bonding is known as ionic bond. Ionic bond means the force of attraction or bond formation can take place between two charged ions is called as ionic bond. Okay, these are the observations are done by Uskosel, and now we are going to discuss with the two or more examples to understand perfectly the ionic bond, how ionic bond takes place between the particles. Okay, right now ionic bond. How ionic bond can take place between two charged particles. Okay, just now we discussed what is ionic bond. What is ionic bond means? Ionic bond means the force of attraction between the two charged particles like ions is called as ionic bond. Okay, Right. The formation of sodium chloride. Formation of sodium chloride. What is the formula of sodium chloride? The formula of sodium chloride is NaCl. NaCl. Right? Then, how bond formation can take place between sodium chloride and that we are going to discuss now. Right? Here we know that ionic bond can take place between one positive ion and negative ion. Okay, that means between cation and anion. Right? So first we have to discuss the formation of cation. Right? Formation of cation. Right. Formation of cation. See here, sodium Na. Its atomic number is 11. Right. Its electronic configuration is 1s2, 2s2, 2p6, 3s1. Right? Okay. Here we discussed that we know every atom is trying to get a stable electronic configuration. What? Stable electronic configuration. Got it? Then how the sodium can get stable electronic configuration? By losing of this electron, outermost electron, valency electron, the electron which is present in outermost shell. By losing this, now it's get octet electronic configuration. Alright? That means 1s2, 2s2, 2p6. Why it is losing, sir? Why it is losing means to get nearest noble gases electronic configuration. The nearest noble gas for the sodium is neon. Neon, its atomic number is 10. Its electronic configuration 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. Right, yes. Then sodium ion, sodium gains the stable electronic configuration by losing one electron. Right? Then by losing one electron, the number of positives are more, no? Then it becomes positively charged one. Right? Positive charged one is called as cation. This is a way to the sodium becomes sodium cation. Okay, why it becomes sodium cation, sir? To get octet electronic configuration, it loses one electron. Okay, right. Next, formation of anion. Okay, formation of anion. Then here chlorine. What is the atomic number of the chlorine? What is atomic number of the chlorine? The chlorine's atomic number is 17. What is this? 17. So its electronic configuration as 1s2, 2s2, 2p6 and 3s2, 3p5. That means 1s2, 2s2, 2p6, 3s2, 3p5. So chlorine is ready to get a stable electronic configuration, its nearest noble gas electronic configuration. Which is the nearest noble gas? Then chlorine is here, right? Here neon, here argon, right? Here its atomic number is 10, its atomic number is 17, its atomic number is 18. Then which is the nearest stable noble gas to the chlorine? That is argon. Isn't it right? It is 7 steps far away. Okay, it is very next one. Then it can able to get a stable electronic configuration of argon by gaining only 1 electron. By gaining 1 electron, it can able to get stable electron. To get a neon's electronic configuration by the chlorine, it should lose the 7 electrons. It should lose the 7 electrons, which is easy to gain. Then it is better to receive 1 electron, to collect 1 electron, or it is better to lose 7 electrons, right? If it is loses the 7 electrons, what happens? If it is loses the 7 electrons, the nuclear charge can increases, then may the charge is destroys. Okay, may chlorine is destroys. So that means it's better to gain 1 electron. It's gain 1 electron. It is loosed here, right? Here it gains 1 electron. It gains 1 electron. Okay, it gains, right? See here, one atom is ready to give, and here one atom is ready to gain. It is ready to gain by gaining by gaining 1 electron. Its electronic configuration becomes 1s2, 2s2, 2p6 and 3s2, 3p6. See, its outermost shell gets stable electronic configuration or not? Right? It's get stable electronic configuration. Then it becomes chlorine minus. It becomes anion. It becomes cation. Right? Here it's by losing it gets cation, by gaining it gets anion. Right? Then one is ready to lose, one is ready to take. Then in between these, now it is positive one, it is negative one. These two are unlike charges. That means in between these two, force of attraction, right? Then in between these two ions, the charged particles, force of attraction can take place, and finally it forms sodium chloride, right? Na plus Cl minus, and finally it becomes NaCl. Then this bond formation is called as ionic bond. This bond formation is called ionic bond. And here you have to notice one thing: positive charged one and negative charged one, and forms a neutral compound. Now sodium chloride is neutral one. Okay, this is positive one, this is negative one, and neutral. Then in ionic compound, in ionic bond, we will get the neutral compound. Got it? Then this is the way to get ionic bond, right? Then here I will explain one more example. I will give you one more example to get perfection. Okay, one more example: formation of magnesium chloride. You know that MgCl2. Okay, now we are going to discuss ionic bond takes place between the magnesium chloride. What is the then formation of cation? Formation of cation. Magnesium, atomic number of the magnesium is 12. Atomic number of magnesium is 12, right? Then its electronic configuration 1s2, 2s2, 2p6, 3s2. 1s2, 2s2, 2p6, 3s2. Okay, right, got it. Then to get octet electronic configuration, it loses these two electrons. To get the nearest noble gas electronic configuration by the magnesium, magnesium is between neon and argon. Magnesium between neon and argon. Right, right now. Then here is the magnesium. So what is the atomic number? 10. Neon's atomic number is 10 and magnesium's 12, argon's 18. So to get argon electronic configuration, it should require 6 electrons. And to get to get neon's electronic configuration, it should lose 2 electrons. Which is better, losing or gaining? Who will give the 6 electrons to the magnesium? No one. So that's why the magnesium loses the 2 electrons. It loses the 2 electrons and it gets the electronic configuration 1s2, 2s2, 2p6. That means nearest noble gases, neon's electronic configuration it will be gets. That means it becomes 2 plus Mg 2 plus. Right, okay. Then here we have chlorine. Chlorine's atomic number 17. Okay. And its electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. Okay, 1s2, 2s2, 3p5. Okay, right. It gets the electronic configuration. It's gain 1 electron. And just before we discussed that, by gaining 1 electron, it gets a stable nearest noble gas electronic configuration, that is argons. That means 1s2, 2s2, 2p6, 3s2, 3p5. Okay, sorry, 3p6. That means a stable electronic configuration. Then it becomes Cl minus. Right. Here we know that force of attraction can take place between the positive charge, that means cation, and anion. Okay, sir. Right here it is ready to lose 2 electrons at a time. Magnesium is ready to get a stable electronic configuration by losing of 2 electrons. These 2 electrons. It is ready to lose. At the same time, the 2 electrons should accept by any other atom. Got it? Right. Here chlorine, sir, chlorine only one charge, one negative, only negative ion. Right. That means it has 2. It required only 1 electron. It ready to lose 2 electrons. That means the one more chlorine can joins with it. This chlorine also required 1 electron and this also is required 1 electron. That means then it becomes 2 chlorines. Each chlorine required 1 electron. Then 2 chlorines, no? How many electrons it required? 2 electrons. Then how many electrons it ready to give? 2 electrons. Then finally that bond formation can take place between magnesium and chlorine, and it gets magnesium chloride. It becomes what? Magnesium chloride. Magnesium chloride. This is the way to practice the ionic bond. Okay, take 2 or 3 examples and practice yourself 2 or 3 times. This concept is very important in 10th class annual examination. Okay, right. Now the force of attraction between unlike charged particles, the ionic bond takes place. Then how ions are arranged, sir? Here we know that electrostatic force is directionless. That means we can't expect one sodium ion can attract only one chlorine ion. Like that, one chlorine ion can attract one sodium ion. We can't say. Okay, that is depends that how many opposite charges can attracted by an atom by an ion is depends on charge on it and at the same time size okay, but the number is fixed. Here sodium ion can attract 6 chlorine ions, and at the same time chlorine ion can attracted by the 6 sodium ions. NaCl crystal possess face central cubic lattice crystal. Okay, then I will show it's a diagram on board. Concentrate carefully. Okay, the red color one shows the chlorine. Okay, and here I am using green color one. It shows the sodium ion. Okay, right now I will show you the diagram. Observe carefully. Okay, then these are sodium ions, right? Okay, then here practice how to draw it. Okay, no, right, concentrate on it. Use scale while practicing. Use scale to get straight lines. Okay, then take the 4 dots here and 4 dots here and join with the line. Then you get one cuboid. Okay, right after, then take sodium ions. Very simple on these lines here. See here one, here one, here one, and here one. Okay, right. Observe where I am keeping the dots, and as it is, I have to practice to get perfect diagram. Okay, first I have it on these lines. The next, here one, here, and here, and here. Right? Join it here, here, and this one, and this one. Okay, right. Next, on these sides and these sides, and next here and here and here and here. Okay, see, join again. What are these 4? Right, and here 1 chlorine. Okay, right, here 1 and here 1, here 1, here 1. Where are the 4 lines are joined? and join these all the lines. Okay. Right, now you can see it. Here, this is the structure of phase central cubic lattice crystal. Here each and every chlorine ion is attracted by the 6 sodium ions, and each one sodium ion is attracted by 6 chlorine ions. Okay, this is the phase central cubic lateral crystalline structure, okay, of sodium chloride. And here, what are the factors affecting the ionic bond? What are the factors affecting the ionic bond? Okay, here we know that then sodium, that means a positive ion, so the force of attraction takes place between positive ions and negative ions. To get the ionic bond, electronegativity between two atoms should be 1.9 or more than 1.9. Okay, na? 1.9 or more than 1.9. Then the ionic bond takes place. And what are the factors are affecting, sir? Here, atomic size and ionization energy and electron affinity and electronegativity. We discussed about atomic size, that means atomic radius, and ionization energy and electron affinity and electron negativity in our periodic classification, right? Here we have a high, right, atomic size and low ionization energy, electron affinity and electronegativity can forms the cations. If atom which has high in atomic size and low in ionization energy, low in electron affinity and low in electron negativity, then forms cations. Like that, the atoms which has low in size, atomic size, and high in ionization energy, electronegativity and electron affinity, then forms anions. Then forms, if it has these features, that forms anion. This is the concept, today's concept, right? These are the factors are affecting the ionic bond. Okay, then in our next class we are going to discuss covalent bond, one more type of bond, covalent bond. Okay, thank you.